Hello, and welcome to ScrapTV, the video forum for the ISRI and Scrap Magazine websites. I'm Kent Kaiser, your ScrapTV host, and today I'm here with Thomas Boundy. Thomas, welcome.
Thank you.
Thomas is the 2016 National Scholarship Winner from the Recycling Research Foundation, and we're going to talk to Thomas today about how he got there and what he's doing that would merit that academic award. So, first of all, why don't you just tell us, Thomas, what your academic credentials are thus far, what you were working on to get to this point.
So I've taken kind of a circuitous route thus far. I was just kind of a generalist coming out of high school and decided to go into chemistry for a bachelor's degree. So I got my chemistry degree at Pepperdine University in California, and there got involved in some research doing air quality monitoring. And that was interesting. As I left Pepperdine, I knew longer term I wanted to go back and get a graduate degree of some sort, but I didn't know what yet. And I found my way into developing different polymers, doing basically aerospace materials research and development, which I really enjoyed. There was a lot of neat design elements in that, being able to use more practical engineering. But I became increasingly interested in what happened once all of those engineered materials were done. Was there a way to find some value in those? And I guess there were kind of three central life principles or things that I've been taught over the years that I've picked up that I have kind of latched onto and that drew me towards scrap. First is you got to clean up after yourself. Okay. Second, there's value in just about anything if you look at it the right way.
Sure.
And then last, that I guess there are a lot of things that happen outside of our awareness. A lot of behind-the-scenes things that are underappreciated but that are deeply valued. Sure. And I guess I see the scrap industry as kind of the center of a lot of those things. And so moving back to graduate school, I found a really nice program that was a good fit for me.
And where are you now? Yeah, tell us where you are now and what you're doing and how that, again, led into a focus on recycling.
So now I'm at the Colorado School of Mines. Okay. So the department that I'm in there is historically all of their mining and mineral processing work. But over the last 10, 15 years, they've really increased their emphasis on secondary materials and scrap recycling. So the work that I'm doing now has to do with electronics recycling and LCDs in particular.
Okay, well that segues perfectly into the next question about, in layman's terms, can you tell us kind of what is the focus of your studies or research, I guess, at this point, and just you know, how it figures into scrap recycling?
So I guess the central question for us was really focused on how can you recover indium from LCD displays. Indium is a rare technologically relevant metal, a tech metal, that's will be increasingly used in solar panel manufacturing and a lot of clean energy applications, but right now it's mostly used in LCD screens.
Sure.
But it occurs at really low levels, so there really needs to be development of some new processing techniques that enable those really small levels of valuable materials dispersed in a very large number of products to be able to be upgraded to levels that can be economically processed. Basically the work has been focused on developing some of these unique techniques that would be low cost enough to be potentially economically viable, and then produce a product that can go into some of the conventional refining facilities.
So the kind of groups that would use this would be like metallic refiners that are already recycling some electronic scrap and whatnot? Or?
Yeah, so there are some different potential embodiments. One would be if the material were valuable enough to actually be able to be shipped to a refiner, then yeah, a refiner could have this potential setup. Or potentially the electronics recyclers themselves could just have another process to tack onto the end of their facility and then send that to a refiner. So it depends on the economics, but that's kind of that's the niche we're trying to fill.
Now, indium, why you focused on indium is that because it's like rhodium terbium like a very, very expensive metal? Or, I mean, how did you just decide indium was the one to focus on? Because I'm sure there's other elements in these products too like that.
There are, yes. So the agency that's been funding us is the Critical Materials Institute. They're a part of the Department of Energy, and their focus is, so they grew out of the rare earth boom of the late 2000s. And they, basically their goal was to secure a domestic supply of a lot of these metals that are important to a clean energy future. So all of the rare earths were kind of their initial portfolio, but there are a couple of these metals like indium, as I mentioned, for solar panel applications that supply could potentially be restricted within the U.S. for a number of reasons. And so identifying a more stable source of indium is of interest to them and of interest to us.
Sure, super. Well, how has the research been going so far, and is there a timeline on when your studies and your research will be done and you'll be ready to move on?
The research has been going pretty well. I'd say pretty well so far. We just published a first paper on the work last month. Basically, we've identified kind of it's a historical mineral processing technique that's been used for soil remediation applications. Basically because it's able to abrade the surface of whatever material is going in. So this glass that has the indium coating on it, that indium coating can be abraded away and recovered. So the work has been going really well on the lab scale, but obviously there are a lot of challenges moving up to a pilot scale and a potentially commercially relevant scale. So we're starting some of those scale-up efforts now. I've got probably another year and a half, 2 years to be working on that. So I'm excited for the progress that we'll hopefully be able to make before I walk out the door. Okay.
And when you do walk out the door, what credential will you have, and I mean, what will you walk into the work world with in terms of academic credential?
So it'll be the PhD degree. Okay. It's the long haul. But yeah, I've long had an interest in being able to ask good questions that produce meaningful results. And I feel like the PhD really, if it's done well, the goal is to train you to be able to ask good questions and then figure out how to answer those questions. So I hope to have some of those skills. And I don't want to just walk right into academia. I'd love to have, I tend to think a more systems-oriented approach to the world, and I often think of things in business terms, and I'd love to be involved in actually bringing about positive change in the recycling industry and being able to contribute to the growth of that. Where exactly that fits, I find myself interested in a lot of the non-ferrous and some of the more rare metals. The electronics industry, recycling industry is interesting to me. But I'm continuing to get to know more companies and more of what the industry looks like, and hopefully we'll have a better answer for you in 2 years.
There you go. So you would like to end up in the industry, it sounds like.
I would.
That's excellent. Well, I wish you luck with that.
Thank you.
Well, best of luck with the research as you go along. We'll look forward to hearing the results and the progress you make.
I appreciate it.
Thank you for being here with me today. And just wrapping up here for ScrapTV, I'm Kent Kaiser, and we will join you again soon.